everyone, and welcome to ChefConf 2021. My name is Kaya Tolliver. I am a developer advocate at Progress, specializing in chef habitat, and I am here with Tim Davis, DevOps advocate at M0. Tim is going to be talking to us today about the pitfalls of infrastructure as code and how to avoid them. And I don't know about you guys, but I'm here for it. Take it away, Tim.
Excellent. Thank you for having me. Thanks for everybody for coming to ChefConf. This is my first time here. So I'm going to go ahead and share this presentation here. Can you see it?
Yep.
We have to have the same kind of Zoom things going on. If everybody's muted, can you see my screen? Yeah, we'll get through all that, right away. All right. So this is my first time presenting at ChefConf. I'm really excited about this. It was definitely really cool to be, selected for this. And this is actually a newer talk for me based off of a blog that I wrote while I was on vacation on a beach, which tends to be when I can crank out, some of what I think is my best pieces of content, just being disconnected from stuff and, kind of just focusing on one thing instead of everything and the craziness of day to day. So hopefully this, is helpful for not only people that are interested in infrastructure as code, just from, square one, but even somebody who may have already started to go that direction and didn't necessarily think about some of these things. Because I speak to people that are looking at infrastructure as code, trying to automate infrastructure as code and stuff like that on a daily basis, I kind of get to see a lot of different things, figure out what a lot of different problems people had were and how they solved them. And I've just kind of put this together into some recommendations and some questions that you may want to ask yourself when you're going through and moving along. So about me, I'm currently the DevOps advocate at an infrastructure as code automation startup, M0. Before that, I was part of the group of people that created cloud and developer advocacy at VMware. Previous to that, I was in the networking and security business unit as a pre-sale systems engineer. And before that, I was an enterprise architect focusing on virtualization and things like that at Dell, and then infrastructure operations for SoftLayer and a few other things before that. Really, if you can kind of see the theme going on here, infrastructure operations is kind of my background. My joke is that I bring the ops to DevOps. Technically, I'm in developer relations and things like that, but I've never really been a super strong developer. But on the infrastructure side of the house, I've always known that the application is king. There's really no point in delivering infrastructure if you're not delivering it for the sake of whatever application you're going to. A lot of that was solidified when I moved into architecture, because with that, you're not just designing infrastructure, you're designing whatever's going to run said application. So working hand in hand with developers, making sure that everybody's getting what they want, making sure that everybody is working together to make the business successful. That's kind of where I come from and what my credentials and qualifications here are. So in agenda, we're just going to wing it. I am going to go step by step. I do have some talking points here and stuff like that, but I always like getting questions. Usually I like to, go off on tangents. I'm here to make sure that you get whatever you want out of this. I believe I will be doing Q&A in this when it ends up going live here. So we can always go through and answer questions, and you can always hit me up on Twitter at VTimD or anything like that if you do have any other questions. So let's jump into it. What is infrastructure as code? The cool thing is that it's exactly what it says it is. It is infrastructure as code. So in the past, on the infrastructure side of the house, everything was very manual, building up servers and storage and networking and things like that. You were actually physically building things. With public cloud and a little more automation and things like that, moving forward in time, it became what is essentially, I guess, known as ClickOps these days. You log into your console, you start clicking around, and you start building exactly what you need. Now, with that, once developers kind of started taking over and started, in smaller shops, startups, and things like that, developers don't necessarily want to go through and do that. Developers speak code. And that's kind of where the infrastructure as code model came from. If developers are already writing code, and why not just write a little more code to build the resources that they need to make that come through. So that's kind of where the infrastructure as code model came from. Obviously, everybody knows, Mitchell Hashimoto and HashiCorp and Terraform. You may not know them specifically, but you've heard of Terraform if you're, at least, even in the zone of knowing what infrastructure as code is at this point. And really that kind of came about from trying to automate infrastructure as code, trying to push that, or trying to automate infrastructure and make that a little easier. And that allows you to kind of fit that more into a developer methodology versus more, click, click, click. I want this, 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 and this. So with infrastructure as code, what kind of pitfalls can occur? There's so many, and we're going to go over nowhere near any of all of them, just kind of some of the big ones that may come up first. And, I kind of have some good news and some bad news along with that when it comes to what types of pitfalls can occur. And, the bad news is that there's a lot. The good news is we already know the answers to a lot of them. With infrastructure as code, not only do you get all of the pitfalls that come along with traditional infrastructure and design and deployments, you also get a lot of the pitfalls that come along with code. Now, bringing all of these together, you have so many of these issues, it seems like a lot. It seems daunting, but really, there have been infrastructure folks for a while. There have been developers for a while. These teams exist generally at most companies, and that brings along all of their experience, all their expertise, all of their knowledge. So bringing these groups together, it does kind of add to the growing list of, issues you could run into, but also you have that wealth of experience that you can always draw on to help bring these together and help answer all of these questions. It really helps to foster that communication between development and between operations to kind of, make sure that what everybody's asking for and what's delivered is exactly what everybody needs. There's an old trope from back in the day, and I may still exist. I'm just not really in the infrastructure operations scene so much anymore, is like developers and infrastructure hate each other. And that used to be the case specifically. Like, I didn't like developers. Developers didn't like me because they thought I was just trying to jam tools at them. And I thought that they were just circumventing me by going out to the cloud and swiping the credit card. And that may have been the case, but it's simply because both of these groups were trying to accomplish the same goal, but they were going about it in a different way. They speak different languages, so to speak, not just like coding language or, English language or what have you, but just different methodologies, different ways of thinking about problems and delivering solutions. And with that, they are trying to deploy infrastructure, run an application on it, make the business successful, but they're not necessarily communicating. And that's really where communication kind of comes through. And that's one pitfall that you can think of right off the bat is if you're trying to solve problems with infrastructure as code, try to foster that communication between any infrastructure or operational teams and the development teams. What are you trying to accomplish? Don't just say, I need a Kubernetes cluster, because the infrastructure person is going to, they're going to say, why? Well, tell them what you're trying to accomplish. I'm trying to deploy a microservice architecture application with Docker containers and things like that. Great. That may be a Kubernetes cluster. Let's try that out. So it's just one of those things where if you kind of have that communication of what are you trying to do? How are you trying to solve that? That can be your first mitigation for a pitfall of going through and how to be successful with infrastructure as code. So let's kind of break this up. We've got a section of infrastructure pitfalls. We've got some code pitfalls. We'll kind of talk through that. Some of them actually kind of overlap, which is cool, but really they're solved, like I just mentioned, in a little bit different ways. So the first biggest one that I come across is, what framework should I use, or what infrastructure as code should I use? And the traditional engineering answer is, it depends. What are you trying to accomplish? What types of applications are you using? What clouds are you using? There's a couple of different types of frameworks, if you just split them up generally, and that's going to be cloud agnostic frameworks, and there's going to be cloud specific frameworks. So you have your cloud agnostic frameworks, such as your Terraforms, your Terragrunts, your Pulumis, and a few others. And then you have cloud specific, where it's going to be ones that are given to you by your cloud provider. So you've got your ARM, you've got your CloudFormation and stuff like that. And that will really kind of help you decide which framework should I choose based on maybe what cloud are you on? Are you 100% in AWS? Are you always going to be in AWS? Is there any chance that you're going to migrate to Google or to Azure, or to, on-prem? Probably not. But you just kind of have to ask yourself, will we always be here? And the reason for that is because if you choose CloudFormation, say in AWS, and you go all in with CloudFormation, and then you've got a new CTO or somebody comes in and says, hey, we got to migrate to Azure. Well, that's going to be a little difficult for you. It's not as easy to migrate a CloudFormation template as if you were to try to, say, use a Terraform. Now, of course, the main thing that I get when I'm, giving a talk like this and I say choose a cloud agnostic framework because it's easier to go between clouds with Terraform is people go, all the providers are different. You're absolutely right. But at least with that, you don't have to learn a different code syntax. It gives you a lot better framework to work off of to be able to, say, reformat that code for the different cloud provider, as opposed to trying to take a CloudFormation template and just straight up convert it to an ARM template. So it's just one of those things where if you make the decision to go cloud agnostic from the beginning, it may save you a little hassle down the road. It'll also give you a little more ability to be free and to use it for other things, because Terraform has providers not just for cloud, but there's also certain SaaS providers that it'll help you work with. There's also some actual even physical hardware, like I believe F5 for load balancers has a Terraform module so that you can work with their platforms. So it just gives you a little more flexibility and a little more freedom if you go for one of those cloud agnostic frameworks like Terraform, Pulumi, or Terragrunt. Within those, each of those even has their own, pros and cons list for that, specifically like with Terraform. Terraform has their own language. It's called HCL. You have to learn the language. You have to learn the syntax to kind of go through that. Of course, there are linters and other things available to help you make sure that you're writing your code properly, that you're not using, bad or, deprecated syntax or anything like that. Pulumi is a little different because it allows you to use the code the type of code you're already running. So if you're making your code, your application in Go or Node.js, there's libraries to help you utilize those languages to help then go through and make your infrastructure as code file. So it allows you to kind of do infrastructure as code without having to write a new language or learn a new language. So as you see, just off selecting which framework here, there's already a plethora of questions that you're going to have to start asking yourselves. And a big pitfall is, making the wrong choice or not knowing what choice to make. There's always tons of documentation and stuff out there to kind of help you and to make that right decision. But really, that's one of the most important things if you haven't started yet, is to do a little bit of research, kind of take a step back and make sure that you're starting out on the right foot. Because if you go down a path for 6, 12, 18, 24 months and you realize you made the wrong choice, it's going to set you back quite a bit going back and fixing that. Security. This is a big thing that happens, and it's not just an afterthought. And this is not just with infrastructure as code. This is with everything. Security, in the past has always just kind of been the last step. Developers have sandboxes that are open and they can go and develop and do what they need and build everything. And then nobody really thinks about, what firewall ports need to be open, what protocols are we using, and things like that, until it's ready to turn this thing over into production. Making security not just an afterthought, but bring it into the design and development lifecycle, especially with infrastructure as code, this can help you out from the very beginning. This way, you're not going through and deploying something that's not correct. You're not deploying any insecure resources or anything. And this brings us to our mitigation with that, and that's shifting left. Now, this is a phrase that you may have heard before. It's very prominent in DevOps and automation and all the things. It essentially means taking a process that's normally pushed to the end of your development cycle or to an application release cycle and just literally shifting it left. And for the longest time, it never clicked with me with what that meant until I actually saw an animation of it where you have like your build, your test, your deploy and stuff like that. And then security. And they just kind of took that and they shifted it left over there after, or before test or during test. So it's literally just taking things that are day 2+ operations like security, checking budget, performance testing, and all of this kind of thing, and moving it closer into the development cycle. This is definitely going to help you out, especially with your infrastructure as code. There are lots of different tools out there that can help you with this that are designed specifically for infrastructure as code. For instance, Terrascan with Accurix or Checkov by Bridgecrew, Open Policy Agent. All of these are frameworks that are designed to work specifically with your infrastructure as code. So you can go through and then say, hey, I'm trying to deploy this. If you're using Terrascan or Checkov, it'll allow you to say, hey, you're trying to deploy an S3 bucket, but you're making this with public permissions. You might not want to do that. You might be putting sensitive data in there, so you want to fix that. Or with Open Policy Agent, you can actually create your own guardrails and your own compliance policy to say they are only allowed to deploy certain sizes of instances. They're only able to deploy to certain regions or with certain IAM policies. These are all things that, with security's help, you can help design these processes into your infrastructure as code deployment processes, so that while you're designing your code, you're making sure to run those tests against them to say, oh, I've designed this thing, incorrectly for security from an infrastructure standpoint. I'm going to go ahead and fix it. Close that feedback loop, fail faster, so that you can keep moving on faster and not have to say, go back 3 weeks instead of just 20 minutes. Making sure that you have the tools, you make the right decisions, and you bring those closer can definitely help you solve some problems for later. So code pitfalls. There are a few of these that are available. Well, there's probably a billion of these, but we're going to go through a couple of big ones that specifically are going to help you out with infrastructure as code. Default values. So to lay this out, when you're going through and you're doing infrastructure as code, you're actually writing a bunch of code files that just say, I want this, this, and this. Or you're saying, I want it to look like this in the end. That's the difference between, going through and writing something and saying, I want everything, and not. That's declarative or imperative. Imperative is going to go through and it's going to deploy step by step. I need a SQL server that has this. I need then this instance that has this. Declarative infrastructure is going to go through and say, this is what I want it to look like in the end. And then your infrastructure as code framework is going to figure out what it needs to do to build all that. When you're doing that, you're just essentially saying, I need an instance. Well, that's great. You need an instance that has what on it, that is what size. Now, certain types of things that you can code may just tell you, I can't deploy an instance because you didn't tell me what type of instance, what size, what connectivity you want, what permissions you want, what operating system you want. But there are certain things that you can write that have default values. So what happens with that? Are you going to inject variables? What variables are you allowed to utilize for that? What is the default for that? And what happens if you leave it blank? So for instance, if there's a type of resource that you're coding in and the default size is much bigger than you would want, you may end up paying a lot more for an instance that you didn't need. So it's just one of those things where you kind of have to, when you're writing your code and you're structuring your code and you're creating these values, you need to know exactly what the defaults might be. And that way you can go through and deploy it out and make sure that every one of those things is covered in your code and called for, so that you're not accidentally messing something up. Like, let's take another example. If you're creating an instance that is connected to a VPC, with that VPC, you may not necessarily know what the default security policy is, and you definitely need that locked down a lot more. Well, by default, it may be set up for allow all. It may not. You never know. You need to find out exactly what the default policies are so that you can account for that before you actually execute that code and go through the deployment. This is another one of those things where when you take those shift left security tools that we talked about, that can help you kind of solve that problem during the development process before you've actually gone through and tried to deploy that out. Mitigating those, Open Policy Agent is definitely a big deal for that. So when you write your policy, this is a good example with coding. It's not just infrastructure as code, there's also X as code. there's pretty much everything at this point. We've got performance as code, we've got security as code, policy as code, and all of that. Open Policy Agent is policy as code. If you're writing your infrastructure as code, you're keeping it in a repository, you're kind of working towards more of a GitOps model, so to speak, where your repository is your single source of truth. Whatever is in the master or main branch, that's going to be, what is out in the cloud. And then you've got pull requests that you're utilizing to go through and make those updates, testing everything within the pull request before it's actually merged back to main. Open Policy Agent is a way that you can take your policy and make that as code as well. Implement that into that same repository so that every single time that infrastructure as code is tested or executed, it's going to go ahead and make sure that your policy is met. So if you have certain default values that you need to check for, if you need to make sure that any of the variables or anything that you're using are within an allowed parameter, you can always design that with Open Policy Agent. And because that is as code, that's another one of those things where it kind of pushes that a little more onto the developer. Now, of course, with anything as code, it's not just saying, hey, the developer's taking over. We don't need infrastructure. We don't need security. We don't need anybody like that anymore, because that's not the case. All of that experience and everything like that comes along with all of the years that you've had, you still need that. This just helps you be able to design that and implement it in such a way that security doesn't have to go yelling at somebody after something bad has been deployed. It's meaning that finance team doesn't have to go yelling at somebody at the end of the month because the bill was bad. Because you've implemented this more directly into the developer's lifecycle, that's being tested every single time. And that'll allow you to kind of mitigate issues of, hey, I'm deploying this. Because when you are automating infrastructure deploys, like you are with infrastructure as code, you might have a little more issues with visibility, making sure that things aren't being deployed that shouldn't be, et cetera. Now, I love this. Dry. Don't repeat yourself. This is a developer methodology that will be exponentially helpful for you down the road if you are doing infrastructure as code for a multitude of reasons when it comes to design and actually writing the code. So when you come with, infrastructure as code, there's a few different ways you can do it. You can absolutely hard code values into the file and then deploy it. No problem. Now, what happens if you want to take that same infrastructure as code file set that you have for production and you want to create dev labs out of it? Well, you're going to have to then go and duplicate that code and have multiple different copies with different values in it. Now, with the dry methodology, that allows you to kind of create variables and other things that you inject at runtime so that it allows you to have a more generic set of infrastructure as code files that you can utilize across a multitude of different environments, just utilizing different variable sets. Like, I'm going to be in a different region. I'm going to have different naming scheme. I'm going to have different IP addressing and security scheme and stuff like that. So that's just one of those things where if you are using the dry methodology, you're definitely going to have a better time. Now, there's lots of different ways that you can utilize this just from writing code, like with Terraform and using TF-var files for that. You can actually also use Terraform modules with that, where you can create, if you are going to have certain modules that you're going to reuse over and over, like this is my VPC, we use the same type of configuration every time, then you can write that VPC module, put it in a module registry, and just call it every single time you need it. It allows you to write all that code one time and then use it everywhere you want. There's also another methodology using TerraGrunt. TerraGrunt is essentially a fancy wrapper for Terraform. A lot of the problems that TerraGrunt solves these days, they pretty much just wrote directly into Terraform open source, so it's not necessarily needed, but it is definitely still a very valid framework and very helpful. And it essentially allows you to create one set of dry code, and then you just put that code where you need it. You call it at the root of the repository, and then you've got a set of configuration files for, say, your VPC, for your EC2 instances, for your development, for your production. And that way, when you need to update a piece of code, you just update that code one time. Now, you may need to update the configuration files for TerraGrunt, but it's a lot smoother of a process instead of, say, having to update the same infrastructure as code files 5 different times. That's what that dry or don't repeat yourself methodology helps you do. Designing for state size. Now, this is something that is very, very important. When you're writing infrastructure as code and you actually go through and deploy, you're going to end up with what's called a state file. Now, this state file is essentially the single source of truth of what's actually deployed. It'll tell you, I deployed an EC2 instance with this name and this full configuration. I connected it to this VPC. I put it in this region. All of that kind of stuff is stored in the state. The reason this is important is because when you go and you make an update and you try to redeploy, your framework will then go through and it will look at that state and see, hey, I already have this out there and they're just trying to add one instance. So instead of tearing everything down and deploying out 4 more instances, I'm going to just deploy 1 instance because they want to go from 3 to 4. So it kind of helps you with performance, knowing what's out there and things like that. The problem with this is if you take everything into one giant set of files and you execute it, you may end up with a really, really huge state file. Now, that's all right because it's easy to manage from a state file perspective because you'd only have one. But from a performance perspective, you may not necessarily want to refresh everything or rerun that whole process if you're just making one tiny little update. So how do we fix this? How do we design for state size? The great news is that we already learned that, and we just learned that a second ago. We're back to that do not repeat yourself or dry methodology. So with this, we talked about that Terraform module. So when you're going through and you're not just making yourself easier on your code for how you're going to design your code, how you're going to store your code, we're now talking about how you execute the code and how that state actually exists when it's deployed. So if you break your code down into reusable modules or more manageable size pieces, that'll be a little bit easier for you on processing. So you can then go through and say, well, I only need to update my VPC. Great. So I'm going to make that commit. I'm going to merge everything over into main, and then it's only going to go through and do the redeploy of that VPC. Now, you may need to do some redeploys and some updates on some other subsequent modules if they are related or they do need that update, but it makes it a little more manageable in the long run. And of course, there are lots of automation platforms that'll allow you to set up workflows that say, if I ever make an update to module A, automatically trigger the update for module B, C, and D. It just kind of allows you to break that up and do a little bit less work, which at the end of the day is really what we're all looking for. Terragrunt, of course, can also help you manage that state size and kind of break up those modules into more manageable pieces. And that's what we have. I didn't want to throw, too much at you here from the beginning. Hopefully a lot of this was great, for you for just some of the basic questions that you might start asking yourself, some of the answers. Maybe we talked about, a certain framework that you weren't familiar for or kind of methodology that you weren't familiar for. This is really meant to kind of either be an introductory or just kind of a catch up for that. If you want more, definitely, feel free to look out there. Feel free to ask me. There's so many different awesome resources out there. I'm sure even people speaking at, Chef Comp specifically here are going to give you some great information. Hopefully this is an awesome show. Again, thank y'all so much for having me. And, if you have any questions, anybody feel free to let me know.
Absolutely. This is great. Thanks so much, Tim. I actually do have a few questions here in the chat for you.
Excellent.
So first, how do I create infrastructure as code, not from scratch, but from what I already have deployed?
Oh, I get that question a lot. That's probably one of the number one questions that I get. A lot of shops that are moving from infrastructure that's already out there and kind of older processes and methodologies that want to move more towards an infrastructure as code in a GitOps type model. They don't have the luxury of being able to, just start over and start fresh. They need to, go with what they've already got. Production is out there. They can't redeploy it. They don't have downtime available. The good news is there's lots of tools out there that can help you with that. And again, it all goes back to the very first thing we talked about of what framework are you working with. If you are choosing to go with Terraform, there are several great tools out there. The number one tool that I've seen is Terraformer. This originally started out as a Google project for GCP, but since then it's actually kind of morphed into something a lot bigger. And even though it is still a Google project, it supports any of the major clouds, GCP, Azure, AWS, but it also does a lot of the not so major clouds, your Oracle clouds, your Ali clouds, and it even does some other SaaS tools and community tools and a few other things. And what it'll do is you actually configure it on your machine or wherever you're going to run it. You install Terraform, you install the Terraformer CLI, you connect it to your cloud account. Essentially, like if you're using Azure, you do AZ login and set that up. And then when you run the command, you essentially tell it, hey, I need you to run Terraformer. I need you to run it against the Google provider. Great. And then you point it at your account. It knows where to log in because it's using those credentials that you set up. And you just tell it what you want. So for example, in Azure, you point it at this one resource group that you need, or you need all of it. You tell it what you want, you execute it. It's then going to not only go out and look for everything that you have that fits that criteria, it's going to build the Terraform files, and then it's actually going to create your very first state file. Because you don't necessarily need to run Terraform apply that time because it's already applied, it's already out there. So it'll break a lot of things up. So if you have instances, you have, VNets, you have security, you have storage, it makes them all in little individual modules, which is great. You may want to bring those together, but it's a really good way of getting a starting point. Instead of just having to try to start fresh or write from scratch, it'll create all of these different Terraform files for you, and it'll create that state file because it is already deployed.
Oh, wow. That's actually pretty awesome. It's a lot of automation and not as much manual, which is great, especially in the DevOps community. One more question around testing. Yep. How do you test your IAC? Is it a pipeline or tell me more about testing?
So it all depends. If you're using a CI/CD pipelining tool or any form of automation tool like that, then you can usually kind of hook those tools in, custom scripted in there. There are other types of automation tools that allow you to do that, but really you have to choose exactly what you're trying to do. You have to find the tool and then just kind of insert that step. Most CI/CD pipelining tools and things like that these days allow you to create custom steps, at which point you can either execute it in a container, execute it against a VM or what have you, and just kind of script out that test. As many tests as you can do and implement into the deployment process, the better. That's essentially going to say, why bother deploying something that's insecure or something somebody accidentally added an extra 0 and it's going to deploy 100 VMs instead of 10. That's going to blow our budget out. You don't want to do that. The more tests that you can bring in and write into your deployment processes, the better. You'd have to look at whatever type of deployment tools you're using now. If you're just going to start fresh, you've never done that before, and you're just, one person doing it on the laptop, then this is just one of those things that you can either script yourself into your deployment processes or, just download the CLIs and execute them against your code repositories before you actually do, the apply.
Awesome. Thanks for that. So we can use something like Test Kitchen, if you will. Cool.
Exactly right.
Shameless plug, Test Kitchen. Great. Definitely enjoyed your talk. It was absolutely informative, and I appreciate you for being on. And if there aren't any more questions, I guess we will close it out here. Thank you, everyone, for joining, and we'll see you at the next talk.